To run reliable services, you must have reliable release processes. When you have many engineers building components of an application, it's crucial that they be able to run unit tests, integration tests, and other test suites quickly. With most user-facing software, teams usually want to release software often with new features and bug fixes. To enable high release velocity, build, test, and release processes must be automated as much as possible. In the module Deploying Applications, you learn the components of a continuous integration and delivery pipeline. You'll learn how to build container images for your application by using Container Builder and push the images to Container Registry. Deployment Manager enables you to treat infrastructure as code. You'll learn how to develop Deployment Manager configurations and templates to create your GCP infrastructure. Continuous integration is a developer workflow in which developers frequently pull from the master and commit their changes into a feature branch in a source code repository such as cloud source repositories or GitHub. This commit triggers a build in a build system such as Jenkins or CircleCI. Continuous integration is a developer workflow in which developers frequently pull from the master and commit their changes into a feature branch into a source code repository such as cloud source repositories or GitHub. This commit triggers a build in a build system such as Jenkins or CircleCI. The build process builds a new application image by using Container Builder and stores it in an artifact repository such as Container Registry. A deployment system such as Spinnaker deploys the artifacts in your cloud environment. You can use Deployment Manager to stand up the resources for the managed services that your application needs. For example, you can use Deployment Manager to create cloud storage buckets and cloud pub subtopics. After your application is deployed in your development environment, you can automatically run tests to verify your code. If all the tests pass, you can merge your changes from the feature branch to the master. Continuous delivery is a workflow that is triggered when changes are pushed to the master repository. The build system builds the code and creates application images. The deployment system deploys the application images to the staging environment and runs integration tests, performance tests, and more. If all tests pass, the build is tagged as a release candidate build. You can manually approve a release candidate build. This approval can trigger deployment to production environments as a canary or blue-green release. You can monitor the performance of your application in the production environment by using monitoring services such as Google Stackdriver. If the new deployment functions optimally, you can switch over your entire traffic to this new release. But if you discover problems, you can also quickly roll back to the last stable release. The continuous deployment workflow varies slightly in that there is no manual approval process. The deployment system automatically releases candidates to the production environment. In the rest of this presentation, you'll consider two key aspects of your cloud-native application: the container image for your application and the Google Cloud Platform resources required by your application. The container image for your application is a complete package that contains the application binary and all the software that's required for the application to run. When you deploy the same container image on your development, test, and production environments, you can be assured that your application will perform exactly the same way in each of these environments. Google Cloud Container Builder is a fully managed service that enables you to set up build pipelines to create a Docker container image for your application and push the image to Google Cloud Container Registry. You don't need to download all build tools and container images to a build machine or manage your own build infrastructure. By using Container Registry and Container Builder, you can create build pipelines that are automatically triggered when you commit code to a repository. In Container Registry, you can create a build trigger that is executed based on a trigger type. A trigger type specifies whether builds should be triggered based on commits to a particular branch in a repository or commits that contain a particular tag. You must also create a build configuration file that specifies the steps in the build pipeline. Steps are analogous to commands or scripts that you execute to build your application. Each build step is a Docker container that's invoked by Container Builder when the build is executed. The step name identifies the container to invoke for that build step. The images attribute contains the name of the container image to be created by this build configuration. Container Builder enables you to specify different types of source repositories, tag container images to enable searches, and create build steps that perform operations such as downloading and processing data without even creating a container image. The build configuration can be specified in a YAML or JSON format file. Container Builder mounts your source code into the /workspace directory of the Docker container associated with a build step. The artifacts produced by each build step are persisted in the /workspace folder and can be used by the following build step. Container Builder automatically pushes the built container image to Container Registry. In Container Registry, you can view the status and history of builds. Container Builder also publishes build status notifications to Google Cloud PubSub. You can subscribe to these notifications to take action based on build status or other attributes. For more information, see the Downloads and Resources pane. Deployment Manager enables you to launch VM instances based on container images that are created by your build pipeline. You can also use Deployment Manager to launch other Google Cloud Platform resources that are required by your application. The Deployment Manager API is integrated into Google Cloud Platform. A deployment configuration defines the cloud resources to provision. The configuration includes the type and properties of the resources that are part of the deployment. A deployment configuration consists of a top-level configuration file in YAML syntax, templates, and additional files. You can declare all your resources in the top-level configuration file for simple deployments. However, for more complex deployments, it's better to define templates that are reusable chunks of configuration. You can then import one or more templates to construct your complete configuration. Deployment Manager will expand these templates to create your final configuration. These reusable templates can be developed using Ginger or Python syntax. Ginger templates and Python code are used to generate YAML configuration. So what's the benefit of using Deployment Manager? Deployment Manager, you can reuse templates and configure resources differently for different environments. For example, you can create test and production environments by using the same deployment configuration with different template properties, environment variables, and conditions. For complex deployments, you can specify dependencies between resources. For example, the creation of a VM might depend on, say, the creation of persistent disks. You can specify startup scripts that are run when the VM launches. These startup scripts might download software or run other commands to configure the VM. You can declare outputs for the template. For example, you can expose the IP address of a database created in a template so that other scripts can connect to the database. For more information about Deployment Manager, see the Downloads and Resources pane.